Now the question is, why wouldn't service providers just leverage the capabilities of cloud? And the reason is the telco reality is a bit different. So you can't actually just run data centers, run compute in a virtualized manner, and expect telco applications to run on that. The telco world is a bit more complex, and it has very different demands. And so for running business-critical applications of service providers, what we refer to usually as network functions, you have to provide a lot more connection to the network. So your cloud cannot just look at the data centers. It has to take into consideration network as well. You can't just look at data centers without thinking of distributions. So you can't have centralized data centers. You have to have distributed cloud nodes. Security is a big issue. Reliability is a big issue. Availability is a big issue. So many of the problems were not yet met with the enterprise cloud. And so knowing that not all clouds were born the same, the carrier cloud was started. So the carrier cloud is a bit different. As we said, it addresses some other topics that were not really met by the enterprise cloud. It started with a connection to the network. So the network is something we would like to leverage not just as a resource for connecting to, but also as something that elasticity can be part of. And so if before elasticity was just for compute resources, for servers, for storage units, now we have to have elasticity in the network level. There has to be more control over the network to ensure performance of applications that run on this cloud. We have to be highly available. The cloud has to provide more reliability levels. So it says here meet or exceed 5 nines. It means very few minutes of downtime every year. Something that you can't really guarantee in the public enterprise cloud. On top of that, we have the distribution factor. So to ensure the performance of applications running on the cloud, we can't really have them just placed anywhere. They have to be somewhat close to the end user to make sure that the experience and the performance are what they should be. They have to be sometimes in specific locations. So if in a normal cloud, or not normal, in an enterprise cloud, we would not really care about geographic locations, and the entire idea would be to separate the physical aspect from the service level. Here, this is not always the case, and we see sometimes telco applications that need to run in a specific jurisdiction. For example, probably the Israeli Defense Force would not really put anything outside of Israel, right? And so location does matter. There is also the matter of flexibility in use cases, because as opposed to enterprise use cases here, we have very, very different needs from different network applications. And so the carrier cloud came to be, and it needed a management system that had to answer quite a few challenges. So we talked about the network, we talked about the data center, and now we have to bridge the gap between the two. Because when we are looking at carrier applications, those have to take into consideration both networking aspects and compute aspects. And we have to make sure that when we look at resource placement, we don't just think of where do we have a data center that has available compute power. This would not be enough. We have to make sure that where we deploy our applications, we have also network availability, that the network is not congested, that the latency is controlled. We have to make sure that we meet the constraints and SLAs that should be met for the specific network application. So if we promise 5 nines, we have to really provide 5 nines. If we promise to put something in Israel, it cannot just migrate to Germany all of a sudden because there was some scaling event in the system. And so these are very interesting challenges that we have to meet. But on top of all of those, the challenge would be to remain open and dynamic. Now this is an interesting one because, as I said before, Cloudbound, well, it's an infrastructure. So we're providing a platform for our users, and we expect service providers to use this platform when they're running their private cloud. So why would we remain open? I mean, it would make the most sense to just develop something that is completely proprietary and lock them in, right? I mean, just get Cloudbound, you're stuck with us, no way around it. So so no, this was not what we wanted to do. When we started this almost 3 years ago, the intention was to build something that is very open, that stays in the industry standards, which did not yet exist, but we'll get to that soon. And that makes sure there is some portability between different management systems of distributed cloud. So, we needed to provide some very sophisticated algorithms that came to be together into one management system. Now, some of these challenges are based in other areas of cloud as well. Some are relatively new and were introduced by the carrier cloud. For example, the fully distributed cloud infrastructure is something that was not as crucial when talking about enterprise applications. But autonomy and the ability to self-monitor and self-heal are things that existed when we were talking about enterprise applications. And so what we decided to do from day one is remain as open as possible and leverage as much of the open source products out there that we can. So I'll give you a little more insight into what is Cloudvan and who we are. 2.5 years ago we were formed. I think R&D started about this time. Our R&D consists right now of around 100 people, and it is mostly centered in Israel. And we're not just consuming open source, and we're not just using OpenStack. We're also contributing back to the community, because as you can probably guess, with the challenges that we are facing, OpenStack is a must. I mean, we can't go around it. We have to support it, and I'll soon show you where. But sometimes there are extensions that have to be added, because the problem set that OpenStack came to address are not exactly those. It was mostly fitted for enterprise clouds and not for the carrier ones. And so we make sure that whenever we come across a problem that is not yet met in the OpenStack standard, we extend the standard. And we make sure that the API does now include this extension. And so when the next problem is met, when another company has to start developing a management system for network-oriented clouds and for making sure that placement is taken into consideration and location is something we're aware of, all of these are already part of the standard because we make sure that we contribute back. What we also love about OpenStack is that it's open source. So we don't just enhance the standard, we can actually contribute back and make sure that we adapt OpenStack to be carrier fitted or adapted at least. So we have quite a few people in R&D, not a few of them are here. So we have around 20 people here in the room, I think. And what we are considering ourselves as a community that not just enjoys using OpenStack and being part of the standard, but also contributing back and making sure that it is enhanced in the way that we need it to. So, important words to close with is that OpenStack is a must. I mean, we would not be developing this infrastructure that we are without making sure that we are part of the industry and we are using the standards that we need to use. OpenStack is something that helped us because it created both standardization and also we could leverage the open source and not reinvent the wheel when we needed to. It's important to also stress out that we use OpenStack both as northbound API and as southbound API. So we make sure that we're not only creating a portable management system, but also the layers underneath that are managed by this are very, very plug-and-play-like. So as long as we support those standards, we make sure that whenever something new comes into the landscape, whether it's a cloud node or a network resource, or anything it is that we can manage, when it's OpenStack compliant, then it can be plugged and played with the system, and it can be managed accordingly. And so we believe OpenStack is the way to go, but we also believe that there's still a way to go, and we want to see OpenStack being enhanced accordingly, supporting this use case as well. It's currently more enterprise-oriented, but we believe together we can get through this journey and make sure it adapts to all different types of clouds.
Questions to Sivan? Yes.
You contrasted the
carrier cloud to the enterprise cloud. But you didn't talk much about the value proposition compared to the public cloud. That's one possible customer. What would be the other use cases for something like that?
So the question is, what are the differences between the clouds and what are the so usually it would not really be given a choice, at least as we see it for our customers. Let's say you're talking to AT&T, and AT&T want to transform their call services, and they want to run it on the cloud to leverage the elasticity capabilities and to save costs. Well, they can't do it if the performance is decreased by moving to the cloud. You have to stay with at least just as good a performance as you had when you're running on dedicated servers and when you're on premise. And so if you're talking about a public cloud, we have quite a few problems here. First of all, it's not distributed well enough. It's not close enough to the end users, probably. The network constraint is a big one because you would have to be connected to private networks of your specific customers. There is also the matter of security and reliability. You can't really guarantee 5.9 availability level with the public cloud with Amazon. And so these are not things that are possible on a public cloud. We actually developed CloudBand as a management system that can support both federated cloud nodes, for example, Amazon or Mars, and also private cloud of the customers. But as we see, mostly service providers will leverage their own private cloud because the public cloud is just, it doesn't meet their needs.
You're talking about OpenStack as an API with Southbound interface as well for the management system. Are we suggesting that OpenStack for our network resources as an alternative for OpenFlow, for example?
Well, it's a very good question about OpenStack and the Southbound. And we believe that an open standard has to be created for really any component that can be managed in a cloud environment. OpenFlow is an interesting topic. We can talk about that later. I think it's a really long discussion. But what we believe is an open standard really has to be there for not just cloud nodes, but for network devices, for orchestration purposes, for any workflow engine that is taken into account in this cloud environment. So there are discussions. There's Tosca, for example, that was mentioned in the previous session. And we believe that some standardization has to occur and that this has to be formalized by the community just to make sure that we can address the problem space in a more efficient way and enable just managing many different resources and not just reinventing and managing infrastructure.
But for now, we're betting on OpenStack for
we are betting on Thank you.
Since data takes a long time to move in a distributed setting, how are you dealing with persistent state? Data takes a long time to move from one site to the other site. How are you dealing with persistent state in distributed settings?
So usually what we would have is hybrid.
Repeat the question.
Yeah, I'm sorry. The question was about data transformation between different, well, if we're a distributed cloud node that is a different geographic location, we would have to just distribute the data accordingly. Copy would take a while. What we aim to do is at the deployment level itself ensure high availability in whatever configuration is needed, whether it's active standby or active-active, and make sure that the replication is something that is ongoing. So the idea is not necessarily to just replicate everything once something goes down, but to be prepared for it and have just a hot standby that is capable of taking charge when it needs to. But this is an interesting question, and it does depend on the network performance that you have connecting to different centers. So you have to take care of your cloud. And as a carrier, you would not just have very low performance of network connecting your different data centers. You would make sure that this is in place as well. Okay, thank you.
Thank you.